Hello class, today we're going to be doing a video on chapter 14 section 2, which is on implicitly defined curves and circles. And so we're going to relate the relationships that we talked about last class with parametric equations with implicitly defined curves. But before we do that, let's take a look at what it means to be implicit. Before we can talk about implicit, let's take a look at the word explicit, stating a fact outright. So in terms of mathematics, an explicit relationship is something that involves where f of x represents the relationship where y is dependent on x. Okay? But implicitly does not state the fact in an outright way, but more in a roundabout way. In other words, you can kind of figure out the direct relationship from the implicit, but not as easily as from the explicit. So for example, here we have x squared plus y squared equals 1. Well, this does involve x and y, but it doesn't exactly explain the relationship between x and y, or which one is dependent on the other. If not, they're both dependent on one another. So how does this apply to what we've been learning? Well, let's take a look at an example. Let's take a look at an example of a set of parametric equations. And this is taken from example 2 from section 14.1. And this describes the path of a robot, where the path is dependent on time t. And for x, it's cosine of t. And for y, it's sine of t. So if I take a look at, let's say the domain of t is from 0 to 6, I see that these are the values for x and y at certain points when t is 0, 1, 2, 3, 4, 5, 6. Well, how will that graph look? Well, let's take a look at the graph. It looks very much like a circle, where here represents time 0, this represents time 1, this represents when time is 2, 3, 4, 5, and 6. Well, why is that the case? Why is the relationship of this parametric equation representing that of, it looks like to be a circular motion? So let's take a look again at the parametric equations. X is equal to cosine of t, y is equal to sine of t. Well, if I want to consider the distance between the points on the path and the origin, I use my trusty old origin relationship, which is 0, 0 is a coordinate pair, and my trusty distance equation between a point, a general point P on the path and the origin. Okay, so we look at something like that. And as you can see, this is the distance formula between a point P, generic point P on the path, and the origin 0, 0. And when we do some simplification, we see that this is also equal to the square root of cosine squared plus sine squared. And from our Pythagorean identities from last semester, we know that that is equal to 1. So we have another way of representing the relationship between the distance between a point on the path and that relationship is x squared plus y squared is equal to 1. And that is an example of a explicit or implicit relationship. Well, I said earlier it was an example of implicit relationship because the relationship between x and y is not clearly identified. So this is an example of a parametric equation represented not explicitly but implicitly. But is there a way to define this relationship explicitly? And there is, because remember, if we want to define the relationship between x and y, we have to set y by itself on one side and solve for x. And so when I do that, I get that y is equal to plus or minus the square root of 1 minus x squared. So we do have a functional type relationship. The only thing I want to point out is that there's actually two equations in one. One is y is equal to plus the square root of 1 minus x squared, and the other is y is equal to negative the square root of 1 minus x squared. So now we have three ways to represent the same graph. We have parametrically, we have implicitly, and now we have explicitly. So now that we've been talking about circles, let's take a look at what another way to look at how circles are defined can be represented. Now, as we said earlier, a circle can be defined, if you remember, as the distance between a point on the circle and the origin is always going to be the same number. And as we saw in the previous example, that distance was 1. But there can be other radiuses as well too. But here's another way to look at what the graph with the circle. But before we do that, let's take a look at what a conic section is. Now, by definition, this is maybe brand new to some of you. Conic sections are curves that can be constructed by slicing a cone. If you remember what a cone looks like. So if I can slice a cone in such a way and the resulting slice, what's the graph or the curve of that, is called a conic section. And there are 4 different types of curves based off how I slice it. Today we're only going to talk about one curve. So if I were to slice that cone this way, it would be a parabola. If I were to slice the cone horizontally, I would get a circle. Okay, and so that's what we're going to focus on in later videos. We're going to talk about the other ways to slice a cone and the resulting curves, i.e. conic sections. But in this case, I can describe this relationship in a parametric sense. For the radius being greater than 0, for r value being greater than 0, the parametric equations of a circle with radius r centered at the point hk look something like this. X is equal to h plus r cosine t, y is equal to k plus r sine t. And if you recall in our last example, our circle had a radius of 1 and the center was at 0, 0. So I can, and for this general form, I can easily move it to what the original form was. Replace, what the previous example form was. Replace h and k with 0 and replace r with 1, and we'll end up with the exact same set of parametric equations. So, and I can also see there is a way to represent that in another way. And the implicit form is what we're going to be calling the standard form of the circle. This is the chosen standard form, and that standard form looks like this. An implicit form for the same circle with radius r and centered at hk, where hk are the coordinates of the center, is this. X minus h squared plus y minus k squared is equal to r squared. And for our example, h and k were 0. And this, substituting that in, we get x minus 0 squared plus y minus 0 squared. And our r was 1. And that's how it relates. So on tomorrow's assessment, you're going to be asked, number 1, to identify, in conclusion, you're going to be asked to identify what type of way the curve is defined, either parametrically, implicitly, or explicitly. And you may be asked to change from one form, either parametric form to implicit form or implicit form to explicit form. And then in terms of equations, you're going to have to be able to represent the standard form of a circle, i.e. the implicit form of a circle given the center of the circle and the radius, or you may be asked to represent it in a parametric form given the center of the circle and the radius. So this video is short, but it's a lot of information, and the notes are online as well. So hopefully you have a good time. See you tomorrow.